Good evening, everyone. Things are about to get real blurry here, and I didn't know we're going to get this stage where it's already very distracting, so I'm pretty sure you can get distracted pretty easily. So for that, I have a very small challenge for you. It's just going to be a mental exercise. I came here prepared with a 50-50 chance that one of you will actually figure out the answer in less than 1 minute. The challenge is very easy. So calculate the sum of all integers from 1 to 100. It is obviously an easy one. It is 1 to 100. So the first one was actually going to answer this, and that's the challenge. Like, I want someone to get the... What? Come on, man, let me finish the question at least. But that was strangely fast. It feels like it was staged. But yeah, I think it might be. But yeah, if you are guessing how did he get it so fast, unless it was staged, I don't know it if it is. But and if it wasn't, the only way he would have done it wouldn't be to go iteratively. Obviously, he wouldn't have the time to go through all the numbers in his head in order to get the answer in time. So the solution would be to use something a little bit more analytical, not iterative, and that will be to see a little, to try to find any kind of patterns here. So the pattern we have here is like we look at the number 1. So if we look at the numbers 1 and then 100, we get the number 101. And then 1 plus 99 is 101. And it seems to be the same for all the numbers. So we have a pattern. We have 101, and then it is 100 times divided by 2. And that's when we get the answer 5050 or 5050. Why did I bring this really very exact example? It is the story of how a young mathematician was discovered in 1784. His name was Carl Friedrich Gauss, and at the age of 7, the teacher was a little bit annoyed because the students were making a lot of noise, and he wanted them to stay a little bit quiet for at least 30 minutes. So these are really young kids, so he gave them this challenge where he wanted them to get the sum of all numbers, and obviously all of them want to do it iteratively. But in a few minutes, this guy named Carl Friedrich Gauss, just at the age of 7, he found the solution analytically, and from there he was discovered, and then he got the Duke gave him a scholarship to go to a university, and then obviously he became one of the most important mathematicians of all time. But that is old news. We go back to the 20th century. I'm going to the App Store looking for like inspirations or app to look at, like UI challenges to work on. And I'm looking at the App Store, and one of them that caught my attention has nothing to do with saving money. It's all about what you are looking at here, which is this card. This card, you will see it on the main page of the App Store. What it says here, or what is interesting about this one here is the blur. So the blur here merges really nicely with the background. So if we take away the blur entirely away from the picture, as you can see, that is the reason why we have it there, is if we don't have the blur, there is no contrast. And I'm sure you have attended at least one accessibility talk during the day where you can see that without contrast, it's really not, really hard to read. So if we add the blur, we are gaining a lot because we are not wasting, we are not adding something abstract as, let's say, a gradient or shading the text itself. So by adding the blur, it looks very nicely. But if we notice very clearly, the only interesting thing about this one is how it merges with the image by itself. It is gradual and progressive. And when I saw that, I started thinking about how can we do this in Flutter. Obviously, the first thing that comes to mind is progressively doing the blur multiple times and try to do it at different values, at different stages of the image, and trying to get something progressive like that. But I know that it has performance issues, but I don't know exactly what's going on behind the scenes. So the first question that comes to my mind is like, if I do it like that, where I implement multiple blurs, what kind of performance application are going to be there? That's my first question. The second one is, can I do it without using progressively, trying to do this multiple times? Is there any other way with the primitives that Flutter provide for blur to do this? And the final one was like, if I go all in, is there a way where I can do this, where I control the logic and I do it progressively, where I let the logic for the progressivity of that animation? And if we take a look at what Flutter provides, if you look in the documentation, look where you can use blur effect. There are three only classes. One is shadow, the other is mask filter, and the other one is image filter. So if we take a look at the shadow, is simply a simple soft shadow where you have a rectangular shape or any other kind of shape, and then you have a duplicate behind it, and then when you apply the blur, as you can see, it starts to nicely fades with the background. So that is shadow. We're definitely sure that it is nice, but it's not going to solve our issue. It's not going to take us where we want. So that is one primitive. We can keep it in mind. The other one is mask filter. Mask filter gives us more possibilities because it's always used behind the scenes for the shadow as well. So here, for example, we can define the blur style, and then if I increase the blur for the images, for the normal one, it's blurring the whole thing. And these are shapes that are implemented in Costume Painter. We just provide them with a mask filter to change them. It can be normal. It can be solid, which is only blurring the outside of the content while keeping the object that we painted the same. And the outer one is obviously excluding the object itself, and the inner one is the one that is used. Obviously, it looks different, and it looks a little bit cheaper compared to the others, but it's still doing it entirely on the inside. So you can use it to create some of those design systems that rely a lot on blur or shadows inside. So that is mask filter. The final one is obviously the one we are looking for, which is image filter. Image filter has few parameters. We can change the filter. We can change filter on the x-axis, and it will blur the content on only one way. And then we can do it only on the y-axis, and it can do it in this way. But what we usually do in our regular development is to do it in a combined way, where the end result is going to look blurred, and we're going to lose a lot of details, and that is the noise that we want to get rid of in a background or in a scrolling picture, for example. So these are the primitives. The question is, are they flexible enough with what we have seen, what we're able to change and what we weren't able to change? The answer, you might have expected me to say no, but it's actually very flexible. We can do a lot of tricks with it, so I'm going to show you a couple of them. The first one is called motion blur. So we have only normal blur with Flutter, but if we use the basic building blocks of knowing the fact that, for example, we can do it only on one axis, we can actually implement a really nice motion blur. So here, as you can see, I used link scroll list so that I can show you the demo here really clearly. So whatever is happening on this list is happening on the other one. So I'm scrolling here. I'm just waiting for the images to load, but you might not be able to see it clearly. So I'm going to try to use the buttons to help me a little bit. Hope all of you can see the difference. One of them is smooth, the other one is not. When you are scrolling so fast, obviously, no matter how fast you are scrolling, there is a limit on how much your eyes can perceive. If we add a little bit of motion blur, and then maybe, for example, now let's do a big jump, you can see the difference much, much better. And the way we do this is obviously still using normal image filter, but the complex part is only just trying to figure out the math for doing the scroll controller. So here I created this very simple parameter that says the max scroll speed, where I'm calculating the speed of our scrolling, so to make sure that if we hit a certain limit, then we enable the blur, but we enable it in a gradual. So we animate the entrance to the blur, and then when we are about to start to cool down, then we start to animate back, so it doesn't feel like there is a glitchiness over there. So this is done with Flutter blur. We don't even have to do anything custom there. Another one would be the lens-like blur. For us, when we think about blur, we only have one image of blur in our heads. But if we go outside of our bubble, for example, ask people who are in photography, and we ask them what's blur. Like, for them, it's going to Tokyo, there is a picture, neon light behind you, taking the picture, and the lights somehow become larger. And that is called the lens or Boken, I don't know how to pronounce it, blur. Obviously, we cannot do something exactly the same, but we can try with the basic building blocks of Flutter, because when we use a filter, we can combine it with others called image filter, and then combine. We can combine it with others. For example, there is a dilation one, and then the erode one. So here I have a preset that defines what. So if I reset everything back, this is the normal image. If I change the blur just by changing the sigma on the x and y axis, this is the normal blur we think about. But there is another effect that we can use with the image filter, which is the dilate one. So if we do it, as you can see, it does some edge detection in order to make the pictures a little bit, the objects, it looks at their edges and try to make them a little bit bigger. Obviously, there is another one, which is erode. It can be used for other effects, but here for our example, what we want to do is to enable dilate and then put it as the, is it going to be, let me see, this is the lens blur by the end. It's a little bit of a blur, the normal blur, combined with a dilate effect with specific values. And as you can see, it looks quite similar, but it is not very similar. But this is all using the building blocks that Flutter provide. The next one is the saturated blur. This is something, if you have ever worked with Cupertino widgets, you will know that there are a couple of fidelity issues in Flutter compared to Material. Material is almost like 100% looking like Material, but for Cupertino, because it's not open source and it is Apple, there is no way for us to tell whether this is correct or not. It's always approximation. So one of them is the Cupertino widgets. They all, especially the ones that they have blur behind them, they always feel like a little bit cloudy. They don't feel like vibrant. And the reason for that is because Apple, when they blur something, they always increase the saturation. And the saturation differentiate when you're in dark mode or when you are in light mode. So this is a normal scroll view where here we are scrolling, and then we have the blur sigma, as you can see here at the top. When I'm scrolling, everything is looking there as we will expect it. But if we combine it with another filter, and the trick here is just to know that with image filter.combine, we can combine any image filter. A blur is an image filter, erode is an image filter, and color filter is an image filter. So what we can do is create the matrix that does the saturation first, and then we apply the blur. Obviously, that ends up with a really bad result because you're going to blur some saturated pixels. What we can do is to do the blurring first, and then we apply the saturation on it. So if I use the light preset here, for example, you will see, I hope that you can see the difference. So color filter, if I change it, you can see the saturation. Obviously, these are very small details, but the good news is there is already a PR open. The last update I got about, from it, there was some external contributor who is actually trying to bring this to Flutter right now to implement this in almost all the Cupertino widgets where they increase the saturation for the blurs. The last update was yesterday, and I think it's going to land on a main branch near you in the next coming weeks. The next one is a smooth edge, because every time we think about blur, we are blurring a rectangular area or an area that we clip. So one way we could try to get something smooth, for example, you can see the problem here, right? Like we have a dynamic image, we don't know what's the content of the image, and we have the text, and the text it does not blend really well with the background. I don't think anyone can read it. But if we blur the content, it's actually readable after that. This is a hover effect, and it is the same for all of these. It's now readable. It's now readable. The trick here is to use an image filter, but combine an image filter, one that does like the blurring for the whole content, but then there is another one that uses a different edge effect, but the code here is actually going to explain the whole trick, but it is just composing two image filters, and both of them are blurring this time. But the only difference is the tile mode. One is clamp. The clamp one is the one where you get like a hard cutoff, like for the rectangular ones. But if you combine it with a decal one, you get the benefits of both of them. That's why I'm applying a different sigma for each one of them, and that's how you end up with a really nice background that is very blurry, and we are not using really huge sigmas here, and at the same time we fix the problem with how we can read the content. Another one will be to apply it with a widget called shader mask, and it will allow us to do something quite similar to the issue we had early on. So if you can see here, we have something quite similar to the image where from the App Store one, and we have a lot of control over it. Obviously, we can control the blur level, and then we can control the progressiveness of the gradient, and that is just using a trick. The trick is that we are rendering the same thing multiple times. It works only in cases where it's not really that expensive of an operation to create the widget multiple times. So if I go, for example, here to show you what's happening, is the shader mask is taking the widget and then taking through the alphas, removing anything that is within the gradient. So we have this image, and then we have the other one that is blurred, and then we try to combine both of them together. So that is the trick there, but as I said, the only caveat to that is that we are like drawing and building the widget multiple times. As you can see, we have like done at least 4 examples. Each of them is different, but it's the same blur. It's the same building blocks. It's just about how we combine them with other widgets. So the building blocks, as an answer, are actually quite very efficient to do other stuff if you figure out a way to hack them together and find a way to use them that way. Yeah, so it is awesome stuff, but as a developer, you cannot go back to sleep if you cannot, like if you're just hacking stuff. You always want an optimal solution where you can control this. You write the logic for defining everything that you are doing. So to do that, we need to break down and understand what is a blur. So let's take a pixelated image. Let's take a pixelated image of Mario, and we want to blur this image. Click blur all the pixels, and then it starts to progressively blur all the pixels. This is the image, and this is the blurred image. What happens between here and there is that we go through each pixel, we take a look at the pixels around it, we do something called convolution, where we read the value of the pixel for each pixel on a different weight. The weight of, for example, if the next one to us is, for example, red, or whatever the color of it, we multiply that with a value here that we are providing. I didn't think that we will not have really big screens, but if you cannot read it, here is that the value here is 0.1. So we multiply it with this value, but that value is going to differentiate as whenever we create a bigger kernel. So the bigger it is, the more blurry it is. So for example, here, if I blur it again, it will be much darker because I had some edge cases to handle, and they are literally the edge cases. So the problem here is that I am at the top edge, right? And they need to read the values of the neighboring colors to me. So I have the neighbors from the left, I have the neighbors from the bottom. What happens at the top and what happens on the other side? Well, that is where the edge mode comes in, which is how you handle it. So tile mode, that is the feature that we, when we decide whether it's decal or mirror. So when we say it's mirror, it just like look at the pixel from the other side and try to get that value. So that's when we do a mirror. Then there is a clamp, which will cause the darkness issue, because it will not have any values. It will take something, some sort of a transparent value, and it will end up having some blackness in your final result. And then there is the decal one, which will smoothly try to come up with not a rotated version of the image, but just like you take the image and you put the image next to it, but it's not mirrored. So it's not like if the final pixel of the picture on this side is going to be red, it's not going to take that one, it's going to take the initial one. So that's the difference between the two. But now that we understand what happens in a blur, I want to just take a quick look at something we usually always do. We go to Figma, right? And when we take a look at what the designer gave us, you take a look at the image, and they have a blur effect applied on it. You see the value says 68. You copy the value, 68. You go back to your design, and then 68. This one is blurred. This one is like, they are totally different. Nothing is similar. Obviously, we have the first clue. This one is called blur, and this one is called sigma. Let's feel a little bit more appreciated, because Figma treats their users as like a top-level users, so they give them just like a value called blur, and it doesn't mean anything. But for us, they give us the real meaning, which is the sigma. So there is a formula that converts to a radius. I will have this here, so most of you will have a solution to this problem. But yeah, so so based on the radius, we're going to produce a sigma. The value is not like 2x or 3x. There is like an approximation to it. That is where you have like to use some sort of a tool in order to generate those values. It's not something that you can calculate in your head. There is no way. So for example, here for a blur, yeah, even the UI gets a little bit stuck because we are printing a lot of text. But for a radius of 8.6, the sigma is 5.47. And the bigger it gets, as you can see, the kernel gets bigger. And the kernel means how many pixels are we going to take a look from all of these sides. So you can see the amount of operations that we are trying to do here. And to explain the amount of operations we are doing, when I click on a blur pixel on a small kernel size, you can see the amount of sampling, multiplying, summing, and dividing that is happening. So for example, let's remember, just this is a simple kernel that doesn't do anything. You will never use this kernel. It is so small. You usually go with like kernels that are like 10 times bigger than this, or let's say we go to a kernel size of 7 to get a little bit of blurriness in a real-life scenario. We go from 2,000 to about 4,000. So you can see the amount of operation is increasing really, really fast. So now the question is, this is just logic, this is Dart, I can write it in Dart, and then I can end up having some really nice control over what I want. So for that, I implemented, or I got an implementation of Dart from the famous library called image. So I click here on the blur effect, it will take this very large image, which is realistic for any application, and I click blur. Yeah, as you can see, the app stuck, and these are slides. So I'm not going to increase the sigma irresponsibly because I don't want my slides to broke. Otherwise, I'm not going to have anything to show you today. So I'm going to go to small, keep it with small sigmas just to show you the errors. Like if you have seen the performance talk, you already know the problem here. So in order to fix it, I have to use an isolate so that at least there is a little bit of offloading of the operation to somewhere else that is not the main UI thread. So now I can safely increase the sigma to something really, really, really large, and I will get some more blurred versions of the image. But what you can see here is the blur duration. The blur duration is nowhere near the 16 milliseconds that we have to do each frame. This is always like 10, 20, 30 times bigger than that. So this is useful, but only for like pre-caching, or when you send an image to someone and you want, like, for example, when you if you have a messaging application and it supports sending really large images, you want to send another version of the image that is very small and blurred, so that for the users, instead of waiting for the final image to load on their devices, they will see the blurred version of it. So it has some useful use cases, and we have, because it's Dart, we have more control over it. It doesn't mean it's useless. It's just slow, and we cannot use it. In our day-to-day life, we want something real-time and real-time processing, and that is where we need the GPU. GPU does that very, very nicely. So here is an explanation of what's the difference. With a GPU, it doesn't do these things one operation after the other. So for the CPU, it's going through each pixel from the top left to the bottom right, one after the other, taking a look at the neighboring pixels, getting the images, and as you can see, the amount of operations, even though it is an M1 or M3 or M whatever, is still going to be not able to do it in the budget we have, which is 16 milliseconds. On the other side, GPU is literally made for this. They can do this very efficiently because that is why it's called a dedicated processing unit. And in order to understand how Flutter end up giving us real-time blur that is so fast as we have seen, take a look at the code. We start from the part where we use image filter, which is image filter.blur. It's a Dart file, but then straight away it takes us to a file that uses FFI to communicate with a function with the engine. So it seems like we're going to the C side. This one here is initiating the blur, and then we sending it to something called Gaussian filter. You remember the guy, right? From the beginning. It wasn't random. The guy, he's Gaussian. He's finding us back again. So it was named after him. It was named after something else, like Gaussian, what's that? A Gaussian distribution. If you have seen that bell curve that looks like this, it is named after that because when we see the kernel, it is distributed in a way that it's always normally distributed, which is obviously another really more interesting topic. But if you are questioning why Gaussian is included, it's always doing this. And we will explain in a bit why we always do this. But the final bit is where the logic to get the values and multiplying them. That's happening in this file called Gaussian.frag, which is a code that is running on the GPU in a language called GLSL. So what do we want really is how can we do something like this. But before we do that, I just want to explain something about the different types of blur. OK, so I'm going to go real quick here. So the different types of blur is obviously you can blur the image or you can blur like something else. Both of these are totally different. For the one where we're blurring the image, we are definitely, the more we increase the sigma, the more it's going to cause the application to use a lot of resources. With the other one, it doesn't. So Gaussian image, obviously, when we filter it, is just going to sample it down, and then it's going to take a look at the kernel and try to do some logic around it. But this is the kernel, and the nice trick that they do is the answer to the question why we use Gaussian blur instead of anything else is because Gaussian is separable. So we don't need to actually do the operation with all the sides all the time. What we need to do is, what can be done is something where we can fetch only on the horizontal line and the vertical line, and then we combine them together. And it is mathematically correct because a Gaussian convoluted with a Gaussian equal Gaussian. So this one takes us from a big O of like n squared to n2, which is obviously a huge drop anyway. The last bit is called the GPU lerp hack, where you actually can get a really nice way of, instead of texturing, getting the values of all the values one by one, you can get almost half of them, because this is something that GPU provides by default. Anyway, I'm going to have to go real quick here. When using rect blur, don't worry, you can increase the sigma or the blur radius, and it's going to be hard. To do customized blurs, you have to use something called GLSL. These are some examples. I will leave them for you for later. If you want to do, for example, a box blur, which is another cheap blur, obviously, as you can see, it's cheap. It's not really good. The lens blur, the real stuff here, it's not a fake one. The images are rounded. And a glassy blur, that is blur, but it is actually totally different, and it is very noisy. A gradual blur, where we can actually control the values of how gradual it is. This is the final example, I promise you. So here, I want to show you what you can do when you have, for example, access to these blurs. I don't think it's working. No, it's working. This is Android. Let's switch to iPhone. This is an iPhone feature. So I'm not sure how many of you have seen this feature before, but when you put two Android devices next to each other, they do this really nice thing. And now that we have control over how we can do that kind of blurring, we can do that. But I'm running out of time, so these are the slides, and this is the code. The code is the slides, because this is a Flutter slide. So if you take a look, you will actually see the code for every example that I've done, because it was already a Flutter thing. I'll have to clap myself here, and thank you.